AI agents are getting incredibly powerful. They can write code, they can browse the web, they can tackle really complex problems. But for all that power, progress has kind of been hitting a wall. So let's dive into this because the real bottleneck isn't what you might think. It's not about capability, it's a chaotic data problem. And today we're going to look at a new protocol that's basically a universal translator, and it promises to just smash that bottleneck wide open. So here's the game plan. We'll start by unpacking the huge problem that's been holding AI agents back. Then, we'll introduce the really elegant solution, the Agent Data Protocol, or ADP for short. We'll get into the weeds of how it actually works, check out the massive performance gains it's delivering, and finally, wrap up with how this could change the entire landscape for the AI community. Okay, so first things first, let's talk about this bottleneck. On the surface, AI agents look unstoppable, right? But behind the scenes, progress has been slowing down. And we really need to ask, why has it been so tough to really scale up their training and make them even better? I mean, we see these agents performing these incredible tasks, but when researchers try to train them on huge amounts of data, the same way they do with other large language models, it just doesn't quite work as well. And the problem isn't that there's a lack of data, not at all. It's the nature of that data that's the real issue. The problem really boils down to just data chaos. First off, creating good data that shows an agent's thought process step by step is super complex and really expensive. But the bigger problem, the one that the researchers call heterogeneity, is the real killer. We have more than a dozen major datasets out there, but every single one of them is like a book written in a completely different language. They all have their own formats, their own structures, which makes it practically impossible to mix them together to train a more powerful agent. And this leads to an absolute engineering nightmare. Just imagine you've got 13 different data sets and you want to use them to train, say, 100 different AI agents. You would literally have to write a custom piece of code for every single one of those combinations. That's what we call a quadratic explosion of work. It's just a tangled mess of duplicated effort all across the entire research community. So this messy, frankly unsustainable problem is exactly what a team of researchers decided to fix. They asked a simple question. What if we could untangle this mess with one single elegant solution? And that brings us to the hero of our story, the Agent Data Protocol, or ADP. Now, the key thing to understand about ADP is that it acts as an interlingua. You can think of it as a common middle language, like a Rosetta Stone for AI agents. It doesn't replace the original datasets, and it doesn't replace the agent's training methods. It just sits in the middle as this universal translator that everything can plug into so all these different systems can finally, speak the same language. And it works so well because of three really smart design principles. First, it's simple. You don't need a PhD in data engineering to use it. Second, it standardizes everything into one single format, which solves that whole different languages problem we just talked about. And third, and this is so crucial, it's expressive. That means it can capture all the complex, nitty-gritty details of what an agent does without losing any important information along the way. So we get why ADP was created, but now let's pop the hood and see how it actually works. How does it take all that data chaos and turn it into something so clean and so useful? The core idea is actually pretty simple. ADP thinks about an agent's entire journey as a trajectory. And that trajectory is just a simple back-and-forth sequence of two things, the actions the agent takes and the observations it gets back from the world. Basically, what it does and then what it sees. I did this, then I saw that. That's it. And these two building blocks are incredibly flexible. An action can be anything, calling a piece of software, writing a block of Python code, or even just sending a chat message. And an observation is whatever comes back, the output from that code or the content of a web page. Just about any complex thing an agent does can be broken down into these simple, standard pieces. So in the real world, this all comes together in a neat three-step pipeline. First, you take a raw dataset and you convert it into that standard ADP format. Then you take that nice, clean data and you format it for what's called Supervised Fine-Tuning, or SFT, which is just the fancy term for training your specific agent. And finally, there's an automated quality check to make sure everything is perfect. It's a really robust and practical system. All right, so the theory is elegant. I think we can all agree on that. But this is where things get really, really exciting. Does all this standardization actually make for better, smarter AI agents? Let's take a look at the results. The headline number is a big one. On average, models that were fine-tuned on a diverse mix of data, all unified by ADP, saw their performance jump by around 20%. Now, this isn't some tiny little tweak. This is a significant leap forward, pretty much across the board. This chart really just says it all, doesn't it? We're looking at how well agents perform on SWE Bench, which is a really difficult test of an agent's ability to solve software engineering problems. So check out the OpenHands agent. The basic model scores a 10.6%. Not bad. But after training on that unified ADP data, its performance just skyrockets to 36.8%. That pattern holds true no matter the model or size. Training with ADP delivers a massive, consistent boost. Now, this next finding is honestly one of the most powerful and maybe a little counterintuitive results from the whole study. You might think that to get good at a specific task, like coding, you should only train on coding data, but the results show the exact opposite. An agent trained only on software engineering data scored 11%, but another agent, trained on the full diverse mix of ADP data, including stuff like web browsing and using tools, scored 16.6% on that exact same coding task. It turns out, diversity makes the agents better and more well-rounded. So the performance gains are crystal clear, but maybe the biggest impact of ADP isn't just the numbers. It's how it completely changes the way the entire AI research community can work. Let's go back to that engineering nightmare for a second. Without ADP, the effort to combine datasets and agents grows quadratically. It's that tangled spaghetti mess. With ADP, it becomes linear. You convert each dataset into ADP just once, and each agent only needs one simple script to read from ADP. It creates this beautiful, clean hub-and-spoke model where everything just plugs right in. And to put a really sharp point on that, researchers estimated that connecting 100 agents to just 13 datasets the old way would require writing almost 500,000 lines of custom code. Just think about that. Almost 500,000 lines of duplicated, wasted effort across the whole community. Now look at the number with the ADP model. That same massive task requires just over 12,000 lines of code. That is a staggering 97% reduction in engineering effort. That completely frees up researchers to focus on actual innovation instead of just wrangling data. And what this all really means is that ADP spreads out that one-time cost of converting a dataset across everybody. So when a brand new, cool dataset is released, only one person has to do the work of converting it to ADP, and boom, instantly everyone in the world can use it. It's a massive catalyst for collaboration, and it just speeds up the pace of innovation for everybody. Which brings us to our final thought. For years, this fragmented data problem has been a hidden brake on the development of AI agents. Now that we have a universal translator to clear that bottleneck, it opens up a really fascinating question. With the freedom to train on these vast, diverse datasets so easily, what incredible new skills and capabilities are these agents going to unlock next?